In this video, we're going to look at some applications of implicit derivatives. As a quick reminder, an implicit derivative, or taking an implicit derivative, basically means that you take the derivative of both sides of an equation and if the variables don't match up, you need to remember to use chain rule. Now I have a video up previously where I explain this a little bit more fully and go through just some more examples of taking them. I'll go through these relatively quickly. If you need more, look back to that video, and eventually I'll get up a related rates problem video which will do some more applications of implicit derivatives. As always, I'll have the times for each of the slides in the description below, so you can click on them to skip to various times. Alright, first example. Find the equation of the line tangent to the curve defined by this at 3, -4. And this is a tilted ellipse. So, two things I need for the equation of the line. I need the point, and they gave us the point, so that makes that easy. The second thing I need is the slope. And so to find the slope, I'll take the derivative of this implicitly. So the derivative of 3x squared with respect to x is 6x. I do not need any more on that thing because the x is lined up. I like taking out the constant multiple, then doing product rule. So the derivative of xy with respect to x is y times the derivative of x plus x times the derivative of y. The derivative of 4y squared will be 8y dy dx, and that will equal 0. And I'll distribute through the 2, so I get 6x plus 2y plus 2x dy dx plus 8y dy dx equals 0. And now I'll try to solve for dy dx, so I'll subtract 6x and 2y from both sides and get 2x dy dx plus 8y dy dx equals -6x minus 2y. I'll factor out the dy dx and be left with, on the left, 2x plus 8y. And to finish this off, I'll divide both sides by 2x plus 8y. And that right here will be my derivative. I'll now use this slope to evaluate this derivative, so the derivative evaluated when xy equals 3, -4 will be -6 times 3 is -18, -2 times -4 is +8, 2 times 3 is 6, 8 times -4 is -32, -18 plus 8 is -10, 6 minus 32 is -26, and I can divide both these by -2 to get 5/13. And so, now using this point and this slope, my tangent line is y equals 5/13 x minus 3 all minus 4. Okay. Now this is a little bit more difficult for a couple of reasons. One reason, I need the second derivative. And the second reason is I've only gotten y, I need x. So the first thing I would do is I'm going to figure out what x-coordinate goes with this. And how I do that is I just use the original equation, substituting 2 in for the y. So I'll have 3x minus x times 2 squared, this is for the point, plus 3 times 2 equals 2. And so I'll get 3x minus 4x plus 6 equals 2. Subtract 6 from both sides, combine like terms. Negative x equals negative 4. X equals 4. And that means I will be at the point 4, 2. Now I need to get to, for concavity, the second derivative. So I'll start the same way as before, taking the first derivative. And the first derivative will be 3 minus, I'll do product rule here and get y squared times 1 plus x times 2y dy dx plus 3 dy dx equals 0. I'll send through the negative. So 3 minus y squared minus 2xy dy dx plus 3 dy dx. And I will move both these to the other side, and that will give me a positive y squared and a negative 3. I'll factor out the dy dx and divide and get negative 2xy plus 3. And we keep on going now, so the final thing I want here isn't just the first derivative, I need the second derivative. So this was the point here, this is for dy dx. Now I need the second derivative, and I do that by taking the derivative of this. Now I'm going to have to get to another slide to get all the way to the answer, and that's alright. So take the derivative again, d squared y dx squared, and I'm going to have to do a little bit of quotient rule here. So in that, I'll take the bottom times the derivative of the top, so that's going to give me negative 2xy plus 3 multiplied by 2y dy dx minus the numerator times the derivative of the bottom, which would be y squared minus 3 times the derivative of this. And in taking the derivative of this, I need to do product rule here. So that's going to be, I'll do it a little bit quickly, so it's going to be negative 2y times the derivative of x minus 2x times the derivative of y. The derivative of 3 is just 0. And I divide this all by the denominator squared. Now, I can try to sort of reduce this down, and one thing that would be useful to do to reduce this down would be to realize that I can replace these dy dx's with this. But I didn't ever say in the problem that I need to find explicitly d squared y dx squared. I just need to find whether it's concave up or concave down. So I basically just need to know whether this is positive or negative. And I'll actually find the full-on value, but I don't need to actually reduce this down. It's going to be a lot of trouble to sort of distribute through, combine like terms, all that stuff, when I can just put in the values and then deal with numbers. So I'm going to have to switch between slides. I sort of apologize for that. So let me get this slide started. So I want to say the second derivative of y with respect to x evaluated at the point 4, 2 will equal. Alright. When I put 4 and 2 into this, I get negative 2 times 4 is negative 8, times 2 is negative 16, plus 3 is negative 13. For this one, now before I evaluate this, let's figure out what dy dx is at 4, 2. So putting 4, 2 in here, I will get 4 squared is 16 minus 3 is 13. So let me put this to the side. Dy dx evaluated at 4, 2 will equal, I'll end up with a 13 in the numerator. No, I won't. That's a lie. 2 squared is 4, minus 3 is 1. I'll end up with a 1 in the numerator. And when I put 4 and 2 down here, I get negative 2 times 4 is negative 8, times 2 is negative 16, plus 3 is negative 13. So I get negative 1 over 13. So when I evaluate this, 2 times 2 times negative 1 over 13, well, 2 times 2 is 4. That would give me negative 4 over 13. I have the minus in the formula. So I put in the y here. So 2 squared is 4, minus 3 is 1. Put them all in here. So negative 2 times 2 is negative 4. Negative 2 times 4 is negative 8. Times negative 1 over 13 is plus 1/13. So negative 4, plus 8 over 13. So negative 4 plus 8 over 13. Okay. And when I put this into the denominator, negative 2 times 4 is negative 8, times 2 is negative 16, plus 3 is negative 13, squared is 169. And now I just need to figure this out. So in here, well, this is nice. We cross off some stuff. Negative 13 times negative 4 over 13 is just positive 4. One times this just gets through there and distribute the negative, so I get a plus 4 minus 8 over 13 all over 169. And I have a few options here. The one I usually like to do is I see a fraction is divided by 13, so I can multiply the top and bottom, the numerator and denominator, by 13. And when I do, 4 times 13 will give me 52. All right, so 52. 4 times 13 gives me 52. Negative 8 over 13 times 13 gives me minus 8. And, well, I guess I'm going to be stuck doing this, so let's do 169 times 13. And so 3 times 9 is 27. 3 times 6 is 18, plus 7 is 25. 3 times 1 is 3, plus 2 is 5. Put the 0, and I get 169. Add them up. 7, 4, 2, 2. And so I'll get 2,247 in the denominator. Hopefully I didn't mess that up. And just combine everything I can. So 52 plus 52 is 104. Minus 8 is 96. And 96 and 2,247 do not have a common factor. Now, even if I mess this up a little bit, the important thing is this is positive, so we will be concave up. Alright, I hope that helped out. I know this last problem kind of whirred out of control, but feel free to comment below if you do have any questions.